In the beginning there is dust, not the dust of ordinary Earth, but the ochre, iron-rusted powder that for eons has swept across the ancient landscapes of a world not our own. Mars, red, cold, and enigmatic, hangs in the black silence, its faint blush visible from our home as a wandering ember. For centuries it has gleamed in the imagination of astronomers and storytellers alike, a symbol of both possibility and peril, a stage for alien dreams and existential dread. The question, are we alone, is nowhere more acute nor more achingly unresolved than on Mars. Long before a human eye glimpsed its surface in detail, Mars was a cipher. Galileo, in 1610, lifts his crude telescope skyward and beholds a wandering star tinged with blood. Later, in the late 19th century, Giovanni Schiaparelli traces enigmatic lines, canali, across the Martian globe, igniting fevered speculation about intelligent life. Percival Lowell, possessed by vision and perhaps by delusion, sketches intricate maps of Martian canals, weaving fantasies of a dying civilization engineering its salvation. The world listens, transfixed, as science and myth commingle. In this fevered dawn, Mars becomes a mirror for our hopes and anxieties. It is not only the object of scientific inquiry, but a screen upon which we project our own fears of extinction, our yearning for connection, and our relentless curiosity. The centuries turn. The canals fade, debunked by sharper instruments and the relentless skepticism of reason. But the longing persists, transformed. If not civilizations, then perhaps, somewhere, sometime, life itself. Microbial, fleeting, fossilized, the humblest of beginnings, echoing our own. It is in this context of longing and skepticism that modern Mars exploration begins. The Mariner missions of the 1960s and 1970s sweep past and orbit the planet, revealing a surface battered by craters and scoured by winds. The first close images disappoint those who hoped for forests or cities, but raise new questions. In 1976, the Viking landers touched down, their sterile arms reaching into the regolith, seeking the telltale signs of metabolism. The results, at once tantalizing and ambiguous, divide the scientific community for decades. Decades pass. New eyes arrive. The Spirit, Opportunity, and Curiosity rovers crawl across ancient lake beds and river deltas, their instruments exquisitely tuned to the chemical whispers of life. Orbiters, Odyssey, Mars Reconnaissance Orbiter, MAVEN, peer through the thin air, mapping minerals and tracking the faintest traces of atmospheric change. Each mission returns a deluge of data, a mosaic of clues that both illuminate and confound. The search for life on Mars becomes a story of fragments, of hints and riddles, of controversy and humility. In the present, the question of Martian life hovers on the threshold of revelation. Recent years have brought discoveries that ripple through the scientific community, igniting debate and wonder. Methane plumes detected by Curiosity and the Trace Gas Orbiter suggest active processes, perhaps biological in origin. Ancient lakebeds layered with clay and sulfate record the memory of water, liquid, persistent, and potentially habitable. Tiny organic molecules, exhumed from the depths by Curiosity's drill, hint at the complex chemistry that precedes life. And in meteorites flung to Earth from Mars, peculiar structures and isotopic signatures stoke hope and skepticism in equal measure. Yet for every clue, there is controversy. Methane, so fragile in Mars's oxidizing atmosphere, fluctuates in mysterious cycles. Is it the breath of bacteria, or merely the exhalation of rocks? Organic molecules, though resilient, may arise from non-biological processes. The Viking experiments remain a battleground of interpretation, their ambiguous signals a touchstone for arguments about contamination, instrument sensitivity, and the very definition of life. Into this maelstrom of discovery and doubt step the new explorers. Perseverance, the most advanced rover ever built, prowls the ancient delta of Jezero Crater, gathering samples destined for return to Earth. The European Space Agency's Rosalind Franklin rover awaits its chance to drill deeper than ever before, seeking pristine samples unscathed by radiation. Orbiters continue their vigilant watch, mapping, sniffing, searching for transient events that might betray life's subtle signature. The stage is set for revelation. The instruments are poised, the questions sharper than ever. And yet, beneath the technical bravado, there is humility, a recognition that Mars is not merely a laboratory, but an alien world with its own history, its own rules, its own secrets. To search for life here is to confront the limits of our knowledge and to reckon with the possibility that the universe is both stranger and more familiar than we can imagine. The story of life on Mars is not a tale of answers, but of questions. It is a narrative written in dust and stone, in spectra and isotopes, in the patient labor of robots and the restless dreams of those who build them. It is a story that demands rigor, patience, and wonder, and it is far from over. To understand the magnitude of recent discoveries, one must first grasp the Martian context. Mars is a world forged in violence, sculpted by water, and frozen in time. Its atmosphere, now thin and cold, once supported rivers and lakes, perhaps even seas. The evidence is etched into the landscape, valley networks meandering for hundreds of kilometers, deltas fanning into ancient basins, minerals that form only in the presence of water. The Mars of today is a desiccated relic, but the Mars of 3.5 billion years ago may have been a crucible for life. The search begins with water, for where there is water, there may be life. Spirit and opportunity, twin rovers born of hope and engineered resilience, trundle across the surface, their wheels churning up history. Opportunity, in particular, discovers hematite spheres, blueberries, that form in liquid water. Both find evidence of ancient hydrothermal systems, environments on Earth teeming with extremophiles. In Gusev Crater, Spirit uncovers silica-rich soils, reminiscent of hot springs in Yellowstone, where microbial mats flourish in boiling pools. These discoveries reshape our understanding of Martian habitability. Water, once thought ephemeral, is revealed as a persistent actor, shaping the landscape for millions of years. But habitability is not life. It is the possibility of life, the stage upon which it might appear. To find life or its traces demands more. The attention turns to chemistry. Curiosity, the nuclear-powered rover that landed in Gale Crater in 2012, is a laboratory on wheels. Its suite of instruments, SAM, CHEMIN, MASTCAM, probe the rocks and dust for organic molecules, the building blocks of biology. In 2018, Curiosity drills into mudstone and discovers a suite of organics, thiophanes, benzene, toluene, and small aliphatic molecules. These compounds, though not evidence of life, are the raw material from which life may emerge. Their preservation over billions of years hints at a benign environment, shielded from radiation and chemical attack. But the most electrifying discovery is methane. On Earth, methane is a fragile gas, easily destroyed by ultraviolet light and reactive oxygen. Its presence in the Martian atmosphere is a puzzle. Curiosity's tunable laser spectrometer detects seasonal variations in methane concentration, with spikes up to 21 parts per billion. The European Trace Gas Orbiter, with far greater sensitivity, finds lower levels, but the signals are intermittent, localized, and difficult to reconcile. Methane can be produced abiotically, by serpentinization, for example, as water reacts with olivine-rich rocks. But on Earth, 95% of atmospheric methane is biological in origin. The Martian methane mystery becomes a crucible for debate, a nexus where geology and biology entwine. In the midst of these contemporary discoveries, the ghosts of Viking linger. In 1976, Viking 1 and 2 landers conduct the first, and until recently, only, in situ life detection experiments on another world. The labeled release experiment, designed by Gilbert Levin, injects nutrients tagged with radioactive carbon into Martian soil. The result? A burst of radioactive gas, suggestive of metabolism. But control experiments and the absence of organic compounds in the soil, according to Viking's GCMS instrument, cast doubt. Was the signal life, or a chemical reaction with perchlorets discovered decades later by Phoenix? The debate endures, undimmed by time. The history of Martian meteorites adds another layer of complexity. In 1996, a team led by David McKay at NASA's Johnson Space Center announces the discovery of possible microfossils in Allen Hills 84001, a meteorite flung from Mars and recovered in Antarctica. Tiny, worm-like structures, polycyclic aromatic hydrocarbons, magnetite crystals, all interpreted as possible relics of ancient Martian microbes. The announcement electrifies the world, drawing praise and skepticism in equal measure. Subsequent studies reveal that such features can form abiotically in the harsh crucible of space and planetary impact. The case remains open, a Rorschach blot for belief and doubt. Controversy is the soul of science, and nowhere more so than in the search for life. Each discovery, each whiff of methane, each organic molecule, is scrutinized, debated, and contextualized within a web of alternative explanations. The preservation of organics, for example, is threatened by cosmic radiation and the relentless oxidizing chemistry of the Martian surface. The detection of methane is complicated by instrument sensitivity, atmospheric dynamics, and the possibility of terrestrial contamination. Even the definition of life, so clear on Earth, becomes slippery when applied to an alien world. Yet the controversies are productive. They drive the design of new instruments, the planning of new missions, the refinement of hypotheses. The Perseverance rover, launched in 2020 and landed in Jezero Crater, carries the most sophisticated astrobiology payload ever sent to another world. Its instruments, Sherlock, Pixel, Supercam, are capable of detecting biosignatures at the microscopic scale, mapping the distribution of organics, and teasing apart the chemical context of ancient sediments. Perseverance is also a collector. Its core samples, carefully sealed in titanium tubes, will one day be returned to Earth by a future sample return mission. In the laboratories of Earth, shielded from contamination and equipped with the full arsenal of analytical techniques, mass spectrometry, electron microscopy, isotopic analysis, scientists hope to scrutinize Martian material with unprecedented rigor. The future of Mars exploration is a tapestry of ambition and caution. The European Space Agency's ExoMars mission, embodied in the Rosalind Franklin rover, is designed to drill 2 meters below the surface, beyond the reach of lethal radiation and oxidants. There, in the cold dark, ancient organic molecules may have survived unscathed for billions of years. ExoMars was delayed by technical and geopolitical challenges, but its promise endures. China, too, has entered the Martian arena. Tianwen-1, orbiter, lander, and rover, arrived in 2021, marking a new era of global exploration. The Zhurong rover, though less instrumented for astrobiology, contributes crucial data on surface chemistry, weather, and geology, expanding the scope of discovery. Mars sample return, the holy grail of planetary science, looms on the horizon. NASA and ESA have joined forces in a multi-mission campaign. Perseverance caches samples, a future lander delivers a fetch rover and ascent vehicle, and an orbiter intercepts the precious cargo for return to Earth. The technical challenges are immense. Autonomous rendezvous, launch from the Martian surface, planetary protection protocols. But the prize is commensurate, the chance to examine Martian material with the full power of Earth's laboratories, to search for isotopic ratios, molecular fossils, and chemical patterns that might betray life. The search for life on Mars is not merely a technical endeavor, but a profound philosophical and existential quest. It forces us to confront the nature of life itself, its definition, its boundaries, its resilience. On Earth, life is tenacious, colonizing the deepest ocean vents, the driest deserts, the most radioactive wastes. The discovery of extremophiles, organisms that thrive in conditions once thought inimical to life, has expanded our sense of the possible. In Yellowstone's boiling pools, in the Antarctic ice, in the acid mines of Spain, life endures, adapts, and persists. Mars, with its transient brines, subsurface ice, and ancient hydrothermal systems, may have offered similar niches. The possibility that life began on Mars, or that it migrated between worlds via meteorites, a hypothesis known as lithopanspermia, forces us to reconsider the uniqueness of Earth. If life is a cosmic imperative, arising wherever conditions permit, then the universe may be teeming with biology, silent and unseen. If, on the other hand, Mars is sterile, if billions of years of opportunity yielded only chemistry, never biology, then life on Earth is an anomaly, a miracle, a singularity in the cosmic order. This tension, between possibility and uniqueness, between the mundane and the miraculous, imbues the search with urgency and humility. It is not only a quest for knowledge, but for meaning. The discovery of life, past or present, on Mars would shatter our anthropocentric assumptions, recast our place in the cosmos, and transform biology into an interplanetary science. It would raise new questions. What is the relationship between Earth life and Martian life? Did they share a common ancestor or arise independently? What is the range of possible biochemistries? Are there forms of life we have not yet imagined, unbound by the constraints of carbon, water, or DNA? The search is also a crucible for technological innovation. The instruments developed for Mars, miniaturized laboratories, automated drills, high-resolution cameras, advance the frontiers of engineering and material science. Planetary protection protocols, designed to prevent contamination of Martian ecosystems and preserve the integrity of samples, force us to develop new sterilization techniques, clean room procedures, and ethical frameworks. The challenge of autonomy, rovers navigating rugged terrain, selecting targets, performing experiments, drives advances in artificial intelligence, robotics, and remote sensing. At the core of these efforts is a community of scientists, engineers, and visionaries, people who devote their lives to the pursuit of a question that may never be answered in their lifetimes. They toil in clean rooms and control centers, in laboratories and conference halls, debating, designing, dreaming. Their work is a testament to the collective power of curiosity, reason, and imagination. Among them are figures whose names have become entwined with the Martian Odyssey: Carl Sagan, whose poetic vision made Mars a symbol of humanity's longing for connection; Gilbert Levin, whose tenacious advocacy for the Viking results kept the flame of possibility alive; Maria Zuber, whose work on gravity mapping revealed the hidden structure of the Martian crust; Ashwin Vasavada, project scientist for Curiosity, orchestrating the ballet of exploration from millions of kilometers away. Their stories, woven into the fabric of discovery, echo the broader human drama. Even as robotic explorers probe the surface, the ultimate ambition lingers: human footprints on Mars. The prospect is both exhilarating and daunting. Human explorers bring intuition, adaptability, and creativity, but also risk contaminating the very environments they seek to study. The ethical dilemmas are profound. How do we balance exploration with preservation? What responsibilities do we bear toward alien ecosystems, even if they are microbial, ancient, or extinct? The search for life on Mars is also a mirror for our own civilization. It forces us to reckon with the fragility of worlds, the impermanence of habitability, the thinness of atmospheres, and the vulnerability of biospheres. Mars, once wet and warm, is now desolate and cold. Its fate is a warning, a reminder that planetary environments are mutable, shaped by forces both internal and external. The loss of Mars's magnetic field, the stripping of its atmosphere by solar wind, the sequestration of carbon dioxide in rocks, these are processes that have analogs on Earth and lessons for our stewardship of our own planet. Amid the grand sweep of science and history, there are moments of exquisite intimacy. The first color image sent home by a rover, the whir of a drill biting into ancient clay, the silent descent of a parachute through pink twilight. There are failures, lost missions, crashed landers, silent orbiters, and triumphs, each celebrated in the quiet camaraderie of control rooms and the collective gasp of a world watching. The search for life on Mars is a tapestry of hope and humility, of rigor and wonder. The present moment is a threshold. The discoveries of recent years, methane plumes, organic molecules, habitable environments, are not answers, but invitations to deeper inquiry. The controversies that swirl around them are not failures, but the lifeblood of science. Each mission, each experiment, each debate adds a thread to the tapestry, weaving a story that is both ancient and new. The future is luminous with possibility. Perseverance continues its patient search, its drill core samples awaiting the return journey. ExoMars, once launched, will probe deeper than ever before. New orbiters, landers, and rovers are on the drawing boards of agencies and private companies alike. The dream of human exploration, though distant, is no longer a fantasy, but a plan, a roadmap, a commitment. In the laboratories of Earth, scientists prepare for the arrival of Martian samples. They refine their techniques, calibrate their instruments, debate protocols, and imagine the questions they will ask. They know that the first answer may be ambiguous, that life, if it ever existed, may have left only the faintest of traces, but they are undaunted. The search is not for certainty, but for understanding, for the expansion of knowledge, the deepening of mystery, the cultivation of wonder. There will be setbacks. There will be false positives and false negatives, dead ends and disappointments. But there will also be moments of revelation, the detection of a biomarker, the recognition of a fossilized cell, the discovery of a chemical pattern that cannot be explained by geology alone. These moments, when they come, will not belong to a single scientist or a single nation, but to the world. The search for life on Mars is, in the end, a search for ourselves. It is the projection of our deepest questions onto the canvas of another world. It is a dialogue between the known and the unknown, the seen and the unseen, the possible and the actual. It is a story that began in myth and fantasy, that matured in skepticism and reason, and that now unfolds in the relentless pursuit of evidence. The discoveries of recent years are milestones, not destinations. Methane plumes, organic molecules, habitable environments. Each is a clue, a fragment, a piece of a puzzle whose final image is unknown. The controversies are not distractions but engines of progress, sharpening the questions, refining the methods, driving the cycle of hypothesis and experiment. The future missions, sample return, deep drilling, human exploration, will bring new tools, new eyes, new minds to the search. They will probe deeper, see farther, analyze more precisely. They may find life, or they may find only the silence of ancient chemistry. Either outcome will be profound. If life is found, if even a single microbe, a single fossil, a single unmistakable biosignature is discovered, then the universe will have spoken. The boundaries of biology will expand. The story of life will become a cosmic narrative, and the isolation of Earth will be ended. If, on the other hand, Mars is sterile, if every experiment, every sample, every analysis yields only the lifeless residue of geology, then the uniqueness of Earth will stand in sharper relief, and the preciousness of life will be magnified. In either case, the search ennobles us. It demands our best science, our deepest humility, our greatest imagination. It connects us to those who came before, Galileo, Schiaparelli, Lowell, and those who will come after, generations who will look up at the red planet and wonder. It is a story without end, a journey without a final destination. In the silence of the Martian night, beneath the cold stars, the rovers continue their work. Their wheels turn, their instruments hum, their cameras gaze unblinking at the alien horizon. Each byte of data, each spectrum, each image is a message from another world, a fragment of a story still unfolding. And as we listen, as we interpret, as we debate, we are changed. The search for life on Mars is not only a scientific endeavor, but a human one. It is a testament to our curiosity, our perseverance, our willingness to confront the unknown. It is, in the end, a story of hope. Mars will keep its secrets a little longer, but the search goes on. In the laboratories and control rooms, in the minds of scientists and dreamers, in the quiet perseverance of machines on a distant world, the question persists. Are we alone? The answer, whatever it may be, will echo across the centuries, reshaping our understanding of life, of the universe, and of ourselves. For now, we wait, we search, we dream. The red planet glimmers in the night sky, a beacon of mystery and possibility. Its dust, once shaped by water and wind, now cradles the hope of discovery. In its silence, we hear the whisper of questions older than memory, deeper than time. And so the story continues, written not only in the language of science, but in the poetry of yearning, the rigor of inquiry, and the quiet courage of those who dare to ask. The search for life on Mars is our story, a story of dust and dreams, of questions and quests, of the eternal longing to know, to reach, to understand. And in that reaching, we find ourselves forever changed, forever searching, forever alive.